Hello and welcome to this repair tutorial, and today we're going to look at a Denon and the model number is UPA F10. In terms of general specifications, continuous power output is 2 times 55 watts into 4 ohms. Frequency response is 20 Hz to 20 kHz. For your inputs you can connect a moving magnet type cartridge via a turntable directly. For your line inputs, CD, tape, tuner, MD and aux. On the rear of the amplifier you have 2 loop jacks. They refer to those inputs as the processor. If you remove them, then you can connect an external preamplifier directly to the power output stage of the amplifier. From the front fascia you can connect headphones directly via the 6.5mm jack socket for private and personal listening. Has individual bass, treble and balance controls. And then dimensions is 270 by 96 by 342. That's width, height and depth. And the weight of the amplifier is 4.5 kilograms. Now when the amplifier was sold new, it would have been part of a stack system, and it would also be provided with a remote control. So if you have the remote control with this amplifier, you can select the inputs of course, and then you can also operate the motorized volume control potentiometer. If we remove the top cover from the amplifier and take this shot here looking internally, you can see that the board layout and the components, it's a very clean design, and also high quality components have been used throughout. On the left hand side you can see that this is a reactance core type transformer. I've put a link in the description for the video for a tutorial which I made a while ago which goes through the different types of transformers, and the reactance core is covered in that video. You can also see vertically mounted the 2 large electrolytic smoothing capacitors, and just towards the front you can just about make out the motor for the motorized volume control. And then as you look towards the rear of the amplifier you have the power output stage, and then to the right you have 2 input boards, and you can't make it out on this photograph, but there is also a speaker protection relay which is near to the rear of the amplifier directly next to the speaker terminals. And then on this photograph what you can see from the side, if we look towards the right hand side nearest to you, there is a large multi-pin IC. That is the input selection IC, and it will be powered from a plus or minus 15 volt supply. Now what was the issue with this amplifier when it came in? Well, the customer had reported intermittent loss of sound, but when we talk about intermittent it was twofold. So i.e. when it happened, it could happen randomly, but what was a little bit strange was that the customer reported that maybe the amplifier could run for maybe 1 or 2 days, then he would switch it off and then switch it back on again, and then the fault would manifest itself, I think, through the left channel. Now normally when that is such a fault, with regard to just intermittent loss of sound, not the nature that it could be 2 or 3 days before the fault appeared, it's normally associated with the speaker protection relay and the contacts becoming oxidised and resistive, and normally replacing that relay will rectify the issue. But although here the customer had reported that he'd actually replaced the relay himself, still couldn't get the fault removed. Now what I did find was there was evidence that this amplifier had been stored in a humid or moist environment. And that adds further complications if you're repairing amplifiers, because what you'll find is that humidity or that moisture will get in contact, for example, on the user control, so inside of the potentiometers, and cause issues associated with intermittent loss of sound. So they need to be taken apart and cleaned. The other thing that you will also find on this amplifier is multiple dry solder joints on different circuit boards, but we'll step through it as we move through the tutorial. So here what we're doing is we're looking from the top of the amplifier down, and the 2 boards that you can see here are the input boards, and there's also an integrated circuit on there for the phono stage as well. Now what I've done is I've just removed them from the main amplifier board in this photograph, and for people who follow along on a regular basis you'll be very familiar with this. So what I do is I just circle around common areas where you need to resolder those connections, and typically what you'll find is anywhere there is a input RCA socket which is subjecting the circuit board and the solder to mechanical stress, this is always an area of focus, so you need to resolder. And then also scan across the board as well. For this amplifier the soldering is a little bit sparse, so you can see some cracking around different components, and because this fault was intermittent, the best thing to do is don't try and fault find it. Just really resolder all of these circuit boards just to eliminate them. And the amplifier is modular in construction, so here what I've done is I've just removed the power output stage of the amplifier. But on this photograph there's a number of things that we need to highlight. If we look towards the right you can see the speaker terminals, and just to the left of those speaker terminals is this speaker protection relay. So this is a 24 volt relay, double pole changeover, and I always replace it as a matter of course. I don't look to maybe try and open up the relay. I always fit a brand new relay. And then you can also see as we move across that board, there are additional RCA sockets. We'll get to that when we look at the underneath of the circuit board. And then, as I said a moment ago, just to the left you can see the input boards, two of them that then plug in. And then on this photograph, what I've done is I've removed that output module. And what you have is dedicated integrated circuits on there. And I'll look at that in a moment in terms of a photograph, because we'll have a zoom in view of the solder side. And the same audio output transistors are mounted underneath. And then what you can just make out here are a couple of multi-pin connectors where it plugs it into the main amp board. But there's also two white connectors with 3 pins each. This is where you will set up your bias adjustment. And then what I've done is I've just flipped the board over and I've made circles around. So you can see here highlighted areas. And you will always find dry solder joints on those driver integrated circuits. Very, very common. And then also on the multi-pin connectors as they connect via the flying leads back to the amp board. And as I said, you can see the Sankin audio output transistors. I also reflow all of this circuit board, and then what I do is I just deflux it just to clean the border after that work has been completed. And then here I've removed the circuit board. This is the main amp board, and again you need to look at these areas which I've highlighted. Always dry solder joints throughout. And then on this photograph what I'm doing is I'm just homing in now on the smaller circuit board, which is used for the headphone socket. Now remember, the headphone socket on many amplifiers has switch terminals. So if you insert the jack plug, it will normally mute the amplifier. And even on this photograph you can see that there is some degree of cracking around those terminals, so you need to reflow them. And then on this photograph what I've done is I've removed the tone control board, and you can see here that there is a series of screws. Now the reason why I've done that is, yes, from the solder side I need to check those solder joints and reflow them, but I need to get access to the potentiometers. I need to get access to the bass, treble and balance control, and then also as well I need to gain access, because it has its own circuit board, to the volume control potentiometer as well. So I'm not looking just to squirt through maybe one of the access holes and then rotate the potentiometers backwards and forwards to clean them. I'm going to strip them apart so I've got full access. And then on this photograph, this is indeed the volume control potentiometer has been taken apart. And just to the right hand side where I've circled, this is the carbon track of the potentiometer, and then the other circle component, which has white plastic and like a metal contact, that is the wiper of the potentiometer. I'm just going to clean that down with De-Oxit D5 just to ensure that any dirt, contamination is completely eliminated. And then here what I've done is I've just reassembled the amplifier. So I'll put the module back in, and we're at the point now where we can then test it. Now for this amplifier, the bias adjustment is a little bit unusual. It's not something that you commonly see, and what they've done, you can see the dedicated IC here listed as IC601, and it's a UPC 1225H. And here what you can see is I'm just pointing to R621, which is a 2K ohm resistor. Now this circuit here is not unique, and what I mean when I say not unique is if you pulled the datasheet for this driver IC, this circuit layout would be seen. But instead of this component, this fixed resistor being in place, the datasheet shows a preset potentiometer, which would be normal, so you can make the adjustment. Here on this amplifier you don't have a preset at all. What you have to do is you have to connect your multimeter across the test points, and then if it's reading higher than 2 millivolts, you have to cut out that resistor there, and it's in parallel of course with the other resistor, and then it will then reduce it down to 2 millivolts or thereabouts. For me, when I checked the left hand channel and the right hand channel, I didn't find any issues, and it was within the 2 millivolt required range. But a little bit strange, but that's what the manufacturer has chosen to do here. And then just to the right of the test point you can see the output transistors, and then of course the emitter resistors here, which are 0.47 for the output stage. And then here, this is the amplifier after we've done the bias checking, and just to the rear of there you can just about make out the blue speaker protection relay. This is a particular relay that I use, very, very high quality, never had any issues, and I've just replaced it as a matter of course. I appreciate the customer also said that they replaced it, but you know, I handle this complete repair from start to finish. so I can't automatically assume that something is good or not good. I just replace it. And then here you can see the relay which was removed. It is a high quality brand. It's a Panasonic relay and it's 24 volt DC. It's a double pole changeover relay. And then finally, in terms of repair and service, the amplifier was put on test for about 4 hours. And because the customer reported this rather intermittent issue where sometimes you turn the amplifier on and sometimes you turned it off and it would reappear, I just did multiple starts of this amplifier. And that's just to ensure, to see if I can sort of pick up if the original fault still exists, but it didn't, and the amplifier ran perfectly. Well, that sort of brings us to the end of this repair tutorial. So as always, I really appreciate you stopping by, and if you need any help, guidance or assistance, by all means email audioamplifierservicing@aol.com and I'll be more than happy to come back to you and provide any guidance and support. So until the next time, I wish you all the very best. Cheers and bye-bye.